First question. The reagents used for separation of acetaldehyde from acetophenone. So there's a mixture of acetaldehyde and acetophenone. And among the given option, we have to choose the proper reagent which will going to separate acetaldehyde and acetophenone. So look at first option, that is NaHSO3. It gives addition reaction with aldehyde and only aliphatic ketones. Acetophenone is the aromatic ketone, so it does not give the addition reaction or addition product with NaHSO3. Aldehydes from the addition product with NaHSO3, which on treatment with acid or base give again aldehyde. So if I write a reaction for this, that is aldehyde, acetaldehyde, that is CH3 C double bond O H, and it's react with NaHSO3. It gives the carbonyl bond breaks down. We are going to get this CH3C OH, this H as it is, and here we get SO3 Na. This on acid hydrolysis, we are going to get acetaldehyde again. While if we react this with acetophenone, that is C6H5 C double bond O CH3 with NaHSO3. So this does not show any reaction. That means when we'll add NaHSO3, only acetaldehyde can do this reaction, while this acetophenone will remain as it is, and we can separate out acetophenone from acetaldehyde by using the reagent NaHSO3. So the correct answer is option A. Next question. The general order of reactivity of carbonyl compounds for nucleophilic addition reaction is. So the size of the alkyl group causes hindrance to the attacking group. As the number and the size of the alkyl group increases, the hindrance to the attack of nucleophile also increases. Thus, reactivity follows the order. It's the lighter molecule, that is the formaldehyde. Then we have acetaldehyde, that is R C double bond O H. Here we have both the H. Here we have one R group. Then we can have AR C double bond OH. That means we have the bigger R group only on one side, so the other side will be open for the nucleophilic attack. Here both the side possibility is there. Next we have a ketone with two R groups, and then the last possibility is the two aryl ring joined as a ketone group. Now looking at this sequence or arrangement for the reactivity of carbonyl compounds, the nucleophilic addition reaction is. So the correct answer, so if you look at the option H2C double bond O, so it's there in option D as well as in option A. Then we have an aldehyde. So option D does not have this aldehyde group. It does directly have a ketone, but we need to have an aldehyde first. Then aryl aldehyde, then a ketone, and then aryl ketone. So the correct answer among the given option is option A, and this is the correct order of reactivity of carbonyl compounds for nucleophilic addition reaction. Next question. This is a acetone CH3CO CH3 can be obtained by. So look at option A, that heating acetaldehyde with methanol. So heating aldehyde with methanol will never going to give us a ketone which is an acetone. That is CH3, C double bond O, CH3. Next is oxidation of propyl alcohol. So if I draw a propyl alcohol, it would be CH3, CH2, CH2, OH. And this on oxidation by using a specific oxidizing agent will going to give you propanol, CH3, CH2, C double bond OH, and not ketone, because we know primary alcohol on oxidation will going to give you aldehyde. So this is not used. Next is oxidation of isopropyl alcohol. So now isopropyl alcohol is this CH3, C, H and OH. So now this is a secondary alcohol, and we know secondary alcohol on using a specific oxidizing agent will going to give you a ketone, that is CH3, C double bond O, CH3. That is the specifically an acetone. So the correct answer for acetone can be obtained by is option C, that is oxidation of isopropyl alcohol. Next question, question 4. Which of the following is incorrect among the given option? Now, FeCl3 is used in detection of phenol. So it's absolutely correct. FeCl3 gives a different pink color solution in phenol, and it does not give any change in color in an alcohols. Next, failing solution is used in detection of glucose. So it's absolutely correct that the failing solution is used in the detection of glucose. Why? Because failing solution oxidizes the aldehyde, which is easily reducible hydrogen, and the glucose has the availability of that particular hydrogen. So this is also correct. Next, Tolan's reagent is used in detection of unsaturation. Now, Tolan's reagent is used for oxidizing or for the detection of aldehydes and ketones. It will not going to detect the unsaturation present in a molecule, that means the presence of double bond or triple bond. So this is absolutely incorrect. So the correct answer for the question 4 is option C. Looking towards the last question, which of the following gives iodoform test? So now the compound having alpha hydrogen atom will give iodoform test. Ethyl alcohol, the option B, and secondary alcohol also give positive iodoform test, because by the action of halogens in alkaline medium, they are oxidized to acetaldehyde and methyl ketone respectively. So among the given option, this formaldehyde cannot give the iodoform test because it does not have the alpha hydrogen available. This is the structure of formaldehyde. This is the structure of ethyl alcohol, and it has alpha hydrogen atom. If we look for the benzyl alcohol, it is benzene ring attached with CH2OH. So this is functional group carbon, and this is alpha carbon. And this is sp2 hybridized with already a branch attached, and it does not contain any alpha hydrogen atom. So this benzyl alcohol can also not give the iodoform test. And the last is benzaldehyde. So it is benzene attached with C double bond OH. So this is a functional group carbon, and this is alpha carbon, and this carbon also does not have alpha hydrogen atom. So this cannot give the iodoform test. So correct answer which can give the iodoform test is option B, that is an ethyl alcohol.